about a week ago sent this out in email, and it's a group from Lincoln Lab up in associated with MIT, uh, talking about sales and how it impacts the severe weather performance and QPE accuracy. I'm really not going to talk too much about the QPE accuracy. I just wanted to show you some things they had found about how sales is impacting warnings across the country. I'm not even going to talk about their motivation. They did assess our sales usage impact on severe weather warning performance for tornadoes, flash floods, and severe, and also the QPE accuracy. One thing I wanted to say before this, I didn't create a new separate PowerPoint because this material has not been cleared for public release, but we can share it within the Weather Service. Their motivation is to see how sales impacts the warning performance and also their QPE accuracy. As we see, these are the slices for the VCPs. You can see the VCP 12 takes 243 seconds. If we add sales, it's 274, 305 seconds for 2, and 336 seconds. Big issue here is it increases the long amount of time we have for volume products, but in sales, we can see that lower cut, and especially with tropical tornadoes, is it beneficial or not? Well, they did not break this study up into tropical or non-tropical tornadoes, but just in all cases. They used Archive 3 data as their data input. They used the Weather Service storm reports that came from NCEI, and the NWS warnings came from the IMCal archive. Flash floods were from the USGS, so forth. Determining radar scan and type used real quickly. They tried to match event and warning locations to the nearest WSR 88D, which you can see the map on the right, very similar to the QPE map that we've seen NSSL use in the past. They find the ASP scan timestamp closest to the warning issuance. And if the warning issuance is greater than the scan timestamp and the time difference is less than 10 minutes for events without warning, they would use the initial event time minus the average warning time. And for flash flood events, locations are first mapped to the source base polygon, like we see in the bottom right here. And the relevant radar measurement is where the rain falls and not the flood area. But let's look at the VCPs and how they've been used. The type of VCP has been used, VCP 212, about 81% of the times for severe, 73% of the time for flash flood, and 89% of the time for tornadoes. Now, sales usage by warning type. Under severe, we see that sales with one scan 48% of the time, 2 scans 17% of the time, and 3 sales cuts 14% of the time, and it was off for 21% of the severe thunderstorm warnings. You can see, I will skip the flash flood, but you can see that 1 scan was on for sales for flash floods. On tornadoes, we see it's a little more usage. For 1, it's off for 8% of the storms. 1 cut, sales cut 35% of the time, 2 cuts 23% of the time, and 3 cuts 34% of the time. So what I wanted to show you is what they had seen during their evaluation of the data. And what they have found is that the severe POD and lead time went up with sales on. The SVR, which is the FVR, which is on the right side, you can see went down with sales. You can see up here, severe with it off, it was about 40 to 50% false alarm. With it on, it dropped 45 to 47%, but you can also notice that 2 was better than 1, and 3 sales scans was not quite as good, but it's pretty statistically not important. So what they found is sales 2 and 3 slices were more impactful than sales 1. So when you go into severe weather mode, it may be more advantageous to use sales 2 or 3 over 1. Now we'll go to severe hail versus thunderstorms. And you can see with it off, the values on is in the blue, and then 2 and 3. What they found is the POD and lead time can be separately computed, but not the false alarm. The same statistical trends were seen with both for overall severe. Sales-associated probability detection and lead time improvements were greater magnitude for thunderstorm wind events than hail events. And since we do very poorly on wind events, it may be advantageous for us to use that 2 or 3 sales scans instead of 1 or none. For flash flood warnings, what they found is no statistical difference in sales between 1, 2, and 3 on POD. The lead time did go up if you use 3 slices versus 1 and 2 in the sales. And the false alarm went down with sales on, but there was no statistical difference between 1, 2, or 3 sales slices. Tornado warnings that came up, we can see those that fly up. Tornado POD went up with sales. 3 sales was better than 2, which was better than 1. Tornado lead times went up for sales. 3 was better than 1 or 2, and that's probably because, especially if you look, most of these are small tornadoes, especially fire area and tropical events. 3 would be more advantageous than 1 or 2. Back to that tornado false alarm went down with sales on 3, and it was better than 1 and 2. Now, what did they find with POD depending on the EF scale? And from past studies, we know the POD goes up when the tornado gets larger. In the EF 0 to 1 here on the left, the results for the sales cuts were essentially the same. There was a slight improvement. So I think maybe 3 would be better for the smaller storms versus 1. And the EF0 results were essentially the same as all EFs. If you see the EF2 to the right here in the middle screen, as long as it's on EF2, we can probably use any 3. I would recommend 2 just for quicker updates for locations, things like that. And the problem with EF3 and 5, we do see there's a good POD anyway, but there was not enough data to make any